Okay, so now we're going to go ahead and we're going to write the formulas for this. Um, with the formula writing, you are going to just deal with charges, and you're going to deal with the prefixes. You are not looking at trying to rename this because it's already named. So first of all, there is kind of a simple rule of thumb as far as figuring out if this is going to be ionic or covalent. If it does not have prefixes, now I have to kind of do the charges. So if I look at here, no prefix, charges, that means positive and negative. Charges, no prefix, charges, no prefix, charges, no prefix, charges, no prefix. The only one that has a prefix is this one, so this is the only one that we would classify as covalent. Again, just kind of look at it, get your little simple clues on it. I gave you the simple clue on it. So on this one now we got to do the charges. So we're going to use this because it is provided for you. So basically you don't even have to look at the periodic table unless you just have to figure out the symbol of this. In this case it's going to be Ti. And then you can write your charges in at any time, but just make sure to do it. Plus fluor, and fluorine is -1. Now the purpose of doing this is to balance this out without having to add and subtract and everything else. Basically your positives go under your negatives, and if you have a -1, you do not have to switch it over here in order to make it balanced. And this is how it's actually going to balance itself out, because now I have 4 positives and 4 negatives. And that would be my final product. Now let's go ahead and go on the next one. I have calcium nitrate. If I focus in on this area, I know I'm going to have a polyatomic ion, and that's one of those things you'll just have to look up on the chart. Hopefully in the future you will actually be able to remember what the symbol's going to be. And I'm going to draw write two separate sets. This is my first one. This is my first set. Now my second set is going to include the nitrate, which is going to be NO3. In this case, I'm going to wait till the end to write my charges, but we know we have to use our charges, and we have to have pluses and minuses because we can't balance it out without both. So if we look at group 2, my charge is a +2. If I look at my chart, it will tell you a negative. If you're looking at your chart and you see there's a negative charge, that's going to be an automatic reminder, hopefully, that you're going to need a positive charge in order to balance these things out. Now, if you're looking at dropping this under the negative, that is fine. But that's going to look a kind of little bit weird. So you just have to remember with polyatomics, we use parentheses. And that would apply to anything that has a 2 that's going to go over here, then you're going to put parentheses. We don't have to worry about it with the negative. And do not put parentheses around here because that doesn't work. If it's a 1, just leave it alone. So that would be your correct formula for that one. This one is kind of great because all I have to do is just write the symbols and write the subscripts. So I got a P with a di, which is a 2, and then my oxide, which is an O, and I got a hexa, which is a 6. I am done. If you take a look at this, I don't worry about the charges because my numbers are already provided for me. Now let's go ahead and do the next one. Now we know now we have to do the charges. This one is provided to you. So you don't have to look on the periodic table and figure out what the charge is. We just use the Roman numeral. So we got M, N, and again we can just go ahead and put that +7 on here because I don't have to really do a lot of searching. And then I have sulfite. That guy there tells you it's off the chart. So 8s and 9s are off the chart. Then I have to put this thing over here, match the symbol. Then I see the charge, again my automatic reminder that I'm going to need a positive. We're going to know that we are unbalanced on this, so I'm going to have moved charges down, not straight down. I'm going to put my negatives under my positives and my positives under the negatives. And then when you see that number other than 1 over here, and you see these three things together, you're going to have to put parentheses around it. Now let's go ahead and go on the next one. We changed it out a little bit. Ammonium is not on the periodic table. So we do have one positive one off the polyatomic chart, or the ion chart, which you're going to have to start using. The ammonium has a symbol. If you take a look at it, it'll probably be the one, or one of the only ones with a positive charge. And then you're going to notice oxide. Well, we see on the polyatomic chart it's a positive charge. Again, we have to do charges, pluses and minuses. And then this one's going to be a -2. Now on this one, I have to move the negative under the positive. So all I'm going to do is move this number here. Since it's off the ion chart, I'm going to have to put parentheses around it. We notice we have a +1. We don't have to put anything there because it's just not going to change anything. And that's going to be my formula for ammonium oxide. On this one's aluminum, and we have acetate. We have our one here. This is a reminder, if you're having problems finding it, it's in the red region, and it's on that little diagonal pattern. So now, I got to write charges. Aluminum, +3. If you don't remember the charge, just look at the chart that's provided with all the charges. And then I have acetate. So I got to write that whole thing. C2H3O2. And then my charge for the acetate is -1. I move my 3 down, but you're going to notice that I have all this stuff here. So again, put the parentheses, put the 3 here. We have this. We can take those away now. And that's going to be my formula for aluminum acetate. The one other thing is, if I'm having to switch this guy back to this, how many words do I have for each of these? I think you would say all of them are 2 words. So when you're naming things, do not use more than 2 words.